Okay, day 2, proving trig identities. So as we work through these, one identity that we'll use more than anything else is your Pythagorean identity. Sine squared of x plus cosine squared of x equals 1. Now remember, an identity is something that's always true. So we can use it when we do proofs, and we can manipulate the equation as well. So we'll look at 2 manipulations of it. If I take the Pythagorean identity and get sine squared alone, I would subtract cosine squared from both sides. That's this equation, which can be used whenever I need it. If I solve the Pythagorean identity for cosine squared, I would subtract sine squared from both sides, resulting in that equation. We can use that as needed. Now the other functions that we've studied, we know tangent can be rewritten as sine divided by cosine. Cosecant is a reciprocal of the sine function. Secant is a reciprocal of the cosine function. And cotangent, depending on what we need, can be rewritten as 1 over tangent, or if we take the reciprocal of sine over cosine, cosine divided by sine. Proving trig identities algebraically, both sides of the equal sign have to be the same. Now we're not solving here. We need to work on each side of the equal sign separately. So we're not going to be moving anything over. We're going to manipulate what we can on the left-hand side, manipulate what we can on the right-hand side, and show that the two sides will eventually equal each other. So rewrite in terms of sine and or cosine. The first thing you should look for is to rewrite any function you can in terms of sine and cosine. When we look at A, secant. Secant is a reciprocal of the cosine function, so I'm going to start there. Sine of x can't be rewritten at all. I can put sine over 1, top times top, bottom times bottom. What's sine divided by cosine? That is what tangent function is defined as. So I end up with tangent on the left, and I started with tangent on the right. So we just proved that that identity is true. Now look at what this says. Prove the following equation. So we have to be able to find an answer. Okay, there's nothing here that would be does not exist, cannot find. B, tangent divided by sine of x equals secant of x. So we got to separate the two sides of the equal sign. Sine is in my denominator, so I'm going to make that its own fraction, times tangent is defined as sine of x over cosine of x. When I multiply fractions, we can cancel. So I have a sign in the top and a sign in the bottom. That leaves me with 1 over cosine of x. And what's 1 over cosine of x defined as? That's our secant function. Secant on the left, secant on the right. I prove the identity. C. Now looking at each side of the equal sign, we'll have to manipulate both sides, but we'll do them separately. Secant is 1 divided by cosine of x. I keep cosine x. I'll just put that over 1. These cancel each other out, and I end up with 1 on the left-hand side of the equal sign. Now to manipulate the right, sine of x, cosecant is a reciprocal of the sine function. Put that over 1. Again, the signs cancel each other out, and I'm left with 1 on the right. So I get simplified function on the left equals simplified function on the right, so we prove the identity. Okay. Cotangent, I'm going to rewrite that as cosine of x divided by sine of x. It's a reciprocal of the tangent function. Sine of x can't be rewritten any further. I'm just going to put that over 1. And then secant is the reciprocal of the cosine function. So when I look at this, I'm multiplying sine on the top, sine on the bottom, cosine on the top, cosine on the bottom. So what am I left with? 1 on the left-hand side. Now when I look to the right-hand side, you've squared trig functions. So whenever you see a squared trig function, go back to the Pythagorean identity. So can I use this fact at all? Sine squared plus cosine squared, the order in which we add does not matter, so this whole sum can be replaced with 1. Left equals the right, identity is proved. KE, cosecant, I'm going to write that as 1 over cosecant of x. Cotangent, I'm going to write that as cosine of x over sine of x. Okay, nothing cancels yet. Cosecant is the reciprocal of the sine function. So 1 over that reciprocal would give me sine of x over 1 times cosine x over sine x. Now I see that the sines cancel. I'm left with cosine x on the right hand side, and that's what we originally had. Or excuse me, cosine x on the left, and then we had cosine x on the right. Okay, so F. So let's see what we have here. I see a set of parentheses, so I'm going to distribute the sign. So we have sine x times cotangent of x plus sine x times cosine of x times tan of x. Alright, sine x can't be rewritten. I'll just put that over 1. Cotangent is defined as cosine divided by sine. Sine x stays put. Cosine x can't be rewritten. Tangent can be written as sine over cosine. Now let me start canceling. Sine on the top, sine on the bottom. I'm left with cosine of x plus cosine on the top cancels with the cosine on the bottom. When I multiply what's left, sine times sine gives me sine squared of x. When I look at the expression on the right hand side, that's exactly what I've ended up with. So we proved the equation to be true. Okay, G. Now proofs, we can use algebraic techniques here. So what we want to look at, you're subtracting 2 terms. So if we think of our factoring rule, when we have subtracted 2 terms, we factored them using the difference of perfect squares. So on the left hand side here, square root of anything to the 4th power would be that thing squared. So I have cosine squared x minus sine squared x times cosine squared x plus sine squared x. Now I'm moving into the right hand side here. This is my Pythagorean identity. Cosine squared x plus sine squared x is equal to 1. So what am I left with on the left hand side? Cosine squared x minus sine squared x. That's exactly what we have on the right hand side of the equation. Oops. Cosine squared minus sine squared of x. Left equals the right, so the equation has been proved. Just a quick note here. The Pythagorean identity is only when you're adding the squares of sine and cosine equals 1. We could see it written as sine squared x plus cosine squared x equals 1, but you can never be subtracting them and then tell me that that expression, that difference is equal to 1. It's only the sum of the 2 squares. Okay, and lastly, so this one's a little more involved, but it does give us a hint. Multiply by the conjugate of the right hand side. So let's start on the right hand side. Cosine of x all over 1 minus sine x. The conjugate, we did that when we were studying square roots. So I'm going to change the sign from the denominator and multiply the top and the bottom by that. Okay, top times top, bottom times bottom. I'm going to keep the numerator in factored form for now. and then the denominator, we're going to FOIL that. First, outer, inner. A negative times a positive gives me a negative sine squared x. Okay, so I'm going to keep the numerator, sine x minus sine x, they cancel each other out. So my denominator is now 1 minus sine squared x. Okay, these won't cancel because they're not the same factors, so we need to work further with the denominator. When you see a squared trig function and a 1, come back to your Pythagorean identity. This is something that's always true, so you can use it as you need it. I need the 1 and the sine squared to be together on the same side. So to manipulate this, I'm going to subtract sine squared from both sides of the equal sign. They cancel. I have cosine squared x equals 1 minus sine squared x. Because this is a true statement, I'm going to replace my entire denominator with cosine squared x. Okay, rewrite my numerator. Now that this is one expression, I have the same one factor in the top, so this cosine from the numerator will cancel with one cosine from the denominator. So I'm left with 1 plus sine of x over cosine x. When I look at the left-hand side, though, I still haven't proved what was originally given. So now this fraction, I can break up a fraction as long as each term from the numerator is divided by the common denominator. So now looking at this, 1 over cosine x, I know that that is my secant function. Sine divided by cosine is my tangent function. So now, again, the order in which we add does not matter. So if I flip the order on the left-hand side, what was originally given on the left, I've now proved on the right-hand side that they are equivalent. Okay, and if you missed class, your homework, complete the 6-6 worksheet. All of it.